the GNC. It really worked out well and was a joy to fly. And I'm guessing it was the first time a space vehicle was flown with a touchscreen before. So we got that going for us. I'm going to hand the mic over to Bob. Well, hello, folks. Welcome aboard the Dragon capsule Endeavour. Doug and I had a good night's sleep last night. We were surprised, I think, at how well we actually slept aboard the vehicle. A little bit quieter than Space Shuttle, a little bit more, I guess, environmentally controlled. So we had didn't have CO2 pockets or things like that building up, giving us congestion, which was super awesome. He talked a little bit about the changing and going back and forth between our suits and our sleepwear and the clothes we're in now, and managing all those things. But we've managed to keep the ship pretty tidy at this point as we went through the night's activities and then got into our preparation for today. We did get our suits dried out, get them packed away into the black bags that are stowed in the outboard seats. You can, if you look closely, you can see we've got them strapped in with the regular straps that you'd use for riding into orbit, and then over against kind of that former window location, there is a, you can see Doug's sleep bag there next to his crew notebook, and so that's how we're keeping all of our laundry constrained floating all around today. Doug mentioned the manual flying and how well the simulator matched that. I'll tell you that for the ride uphill on Ascent, they just are never able to capture that at the simulator. And so I think Doug and I were talking about all the observations that we had all the way uphill. While it was an exciting ride, I think we got a couple of minor surprises just in terms of the way the vehicle is kind of moving and shaking and taking you into orbit. You can tell that it's fighting against the Earth as it makes its way into space, and that's just something a simulator can never truly simulate. We do have a friend on board with us. We introduced you to Trimmer yesterday when we did our little activity with the camera. Trimmer also had a good night's sleep. I know that both of our sons are pretty happy about that with their pet dinosaur making it into orbit and having a good night in zero gravity. We plan, once we get on board the space station, to reunite Trimmer with Earthy and plan to bring both of them back to Earth. I know that we'll get Trimmer through the safety brief and get all the education that's required so that we'll have a safe operation while we're on board the space station should anything come up that we need to be prepared for. I know that Trimmer's also looking forward to helping us out with EVA preparations, just in case we need to do a spacewalk, and so we're looking forward to that as well.
2 minutes until LOS.
Let's see, I think we'll go ahead and bring the camera out a little bit, and we'll show you what's going on underneath the seats on board the Dragon capsule Endeavour. We've got quite a bit of cargo that we'll be taking to the space station. We've got some hard racks as well. The hard stowage that we have can also be swapped, these hard containers here, for powered cargo, which lets us bring back refrigerated things from the International Space Station. And if you're super lucky, we don't have that this time, but I bet you some crew will take ice cream to the International Space Station with those. That'll be exciting for those crews to get to have that. We do have some emergency equipment labeled in red, which is nice to have and easy to see, as well as the other stowage bags that we have down here as well. I don't know if you were watching closely during our strap-in and insertion on the pad, but we did have the seats rotate at one point. We were down in an easier configuration to ingress the vehicle in, so when we climbed aboard, the seats were rotated down, and after we were strapped in, they rotated up. our activities. And so those seats will rotate again in preparation for splashdown when we eventually come home. So if any of you all know Uncle Kirk Shireman, as we call him, you could ask him when we're coming home and make sure that he starts having a plan for us.
Well, we appreciate you having them coming on board again with us on Endeavor, and enjoyed showing you around both inside and out. The next time we'll be on video for you. We'll hopefully be on board Chris Cass in just hours. So we appreciate you stopping by and from Endeavor.
All right, it looks like
Dragon SpaceX, thank you so much. That was a great event.
it looks like they wrapped up right as we went into.
We enjoyed it. Hopefully everybody else did too. We're going to go ahead and put the floater cam back in the compartment, and if there's anything else you need, just let us know.
And Dragon SpaceX, thanks. We all really enjoyed it down here. And if you don't mind holding that floater camera out still until we confirm it is off, and I will give you that go to return it once we have turned it off.
No response needed, but if you're ready, we're ready early on the Node 2 hatch, so you have a go at any time to open the Node 2 hatch. Reminder not to ingress
all right,
off that yet, because we will be ventilating it. But go to open.
I'll put that in work right now.
Pretty cool there to get an inside look into the capsule a second time. Tremor looks like he's having a lot of fun. Bob and Doug also look like they're having a lot of fun. You know, can we just call them and ask for a few more views of Earth? They said they were going to keep that camera out for some stuff, right?
I definitely wish we could be in there the whole way, but we do have a couple of more major steps coming up as they are continuing to close in on the International Space Station. During that time with them inside the capsule, we passed the rendezvous complete stage, and so now we're just moving up on the approach initiation. In about 20 minutes, we're going to do something called the approach out of plane burn. And this was described to me by our lead flight director over in Houston, Zeb Scoville. As you're doing these approaches, you might have a little bit of margin that you need to clean up, and so they can do this out of plane burn just to get exactly where they want to be for that approach initiation, which we are targeting to come right at about, pull my time up again, right at about 5:09 a.m. Pacific, so in a little over an hour from now, 12:09 UTC or GMT. And that's the burn that's really going to begin putting us really close to the International Space Station.
Yeah, as we were talking about, you know, out of plane versus in plane, if you imagine the International Space Station on sort of a flat sheet as it's going around the Earth, that's the plane of its orbit. And we're trying to make sure that the Dragon spacecraft and the International Space Station are on that same plane. Right now, the two are both co-elliptic, so they should be pretty close. But this small out of plane burn will help us do any small corrections that we need to do so we can get that more or less perfect for the flight.
And in the meantime, we did hear that on board the International Space Station, Chris Cassidy getting the go to open up the Node 2 hatch. And so Node 2 is where they're going to be docking to today on the very forward end. There is a hatch between Node 2 itself and the pressurized mating adapter. So Chris Cassidy's going to get the go to open that up. He's not going to go inside yet. They're going to install some ducting to begin circulating some air through the pressurized mating adapter itself. And then once that's complete, he'll be able to get the APAS hatch, so the hatch on the station side configured, and that's exposed to the vacuum of space right now. And then once the Dragon docks, that will form what's called the vestibule, so two different sides of hatches normally exposed to the vacuum of space will form a tight link, and then they'll be able to pressurize that section before they actually get those hatches open.
Yeah, that's right. Dragon will be docking to the international docking adapter, which is attached to that pressurized mating adapter, PMA, as you might hear it called, as we're listening into calls on the nets. The fun fact that both of the international docking adapters actually flew up on previous Dragon CRS missions. So the adapter on the V-bar, so that's, if you imagine the windward direction, as Dan had mentioned earlier, of the space station traveling through, that is where the Dragon capsule today will be targeting for docking. And actually, it's only been used once before for the Demonstration 1 mission, when that vehicle docked to space station.
Yeah, we have 2 of those docking adapters on the station right now. We're once again using that one in the forward part of Node 2. The other one is on a pressurized mating adapter on the zenith part of Node 2. Zenith is just the space-facing side of the International Space Station. So if you're inside and just looking up away from planet Earth, you're looking zenith. And so we'll have 2 docking adapters available for any vehicles using these international docking standards. And that's obviously the Crew Dragon, which is also a version of it going to be carrying cargo up on SpaceX's resupply missions in the future. And then somewhere down the road, we'll have the Boeing Starliner. So, I mean, we'll be in a reality where we could have 2 brand new spacecraft docked to the International Space Station at the same time. Could even have 2 Dragons there at the exact same time. We haven't used that Zenith port yet. We will have to down the road inevitably, as one thing that we're going to be looking to do is something called direct handovers. And so right now we do a lot of indirect handovers on the International Space Station, where you have one group leave, and for a period of time you only have 3 people on board, and then until another group shows up. With direct handovers, you can have 2 vehicles docked at the same time, and so you don't have those long periods of only having about 3 crew members on board. We've only had 3 crew on board since Expedition 62 ended, with Chris Cassidy the only U.S. crew member on board right now.
Yeah, so I'm sure he's excited to have 2 more U.S. crew members join him. People I'm sure he's trained with, and people. He actually flew with Doug on the last, not the last STS mission. You mentioned a mission he flew with him.
Yeah, Cassidy flew with Doug on STS 127. That was back in 2009.
Dragon SpaceX for 3 items.
Just give us 1 second up here, and we'll be right with you.
Copy. Sounds great.
So I think the core there giving Dragon a call, probably for that rendezvous completion, and then some words about what they'll be stepping into next.
Again, the core right now is Anna Manon. She's going to be the one on console here for all of our approach and docking maneuvers coming up over the next several hours. She's the one talking directly to the crew, Bob and Doug on board Crew Dragon, doing that from Hawthorne Mission Control right behind us. Core, a brand new position in human space flight. This is the first mission it's been used on, so we've had a couple cycle through already. Just going through their different shifts with the different control teams as they shift around. As I mean, when we have humans in space, we're pretty much going around the clock. I know that the...
Go ahead for those 3 items, Anna.
At this point, you are go to stow the floater camera, and I have the burn time for approach initiation when you are ready to copy.
Houston, no 2 forward hatch open. Station, we copy, no 2 forward hatch open.
Go to the floater, and we're ready to copy.
The burn time for approach initiation is 1209 UTC. Note that you will see approximately 1213 for the time in your displays, but we expect it to trend towards 1209.
Okay, new time for AI, 12:09. We'll see 12:13 on the displays, but it'll trend back towards 09. How copy?
Good copy. And I thirdly have a request regarding the handheld gas detectors when you are ready to copy.
Josh, a couple days ago we had a question whether or not the
hatch holding mechanism was in there, and it is. We had previously grabbed
We have a request for you to please turn on the fire detector handheld gas detectors. Those are numbers 1 and 2.
Copy that.
And report readings of CO, HCl, and HCN. Then turn the draggers off, confirm they are off, and restow.
Okay, we'll turn on detectors 1 and 2. We'll get CO, HCl, and HCN readings, and then we will turn them off.
Thank you so much.
All right, so the core here in Hawthorne just running down a couple of items with Bob and Doug. One of the ones right at the top is that next big milestone that we're really looking out for, and that's that approach initiation burn. Before that happens, we'll get into the integrated operations between the team here in Hawthorne and the team out in Houston.
Yeah, that's right. The integrated operations really represents a close partnership between the operations teams both in both sites. And that's because we're getting really close to space station. So we want both the teams in Hawthorne who are able to control the Dragon spacecraft and give real-time updates to how it's performing and how the systems are functioning. We want them to be completely synced up with the International Space Station. And the space station also needs to be ready to go to allow approach initiation to enter into the approach ellipsoid around the space station.
And speaking of the space station, we're getting some live views inside of Node 2. We just saw him on screen. He's floating out to get some tools for the actual hatch operations for Dragon, but this is a live view inside the International Space Station. We'll see Expedition 63 Commander Chris Cassidy in there getting the hatchway open. You can see kind of at the very far end a space that looks like it kind of dips down and then goes to a small white hatch. That's the pressurized mating adapter. So that's the attachment point, really, along with the International Docking Adapter between Dragon and the International Space Station. So there's a small corridor that's now exposed. Chris opened up the hatchway on Node 2 to open that up and begin circulating air through it. And there we can see him floating once again into screen. Or actually, that looks like Russian cosmonaut Anatoly Ivanishin, who's just going to be assisting with some of the hatch opening ops. But Chris Cassidy is going to be our prime. He's been training for this on board, and we're going to see him quite a bit once we get to that hatch opening in just a couple of hours.
Yeah, and you mentioned, circulating some air in there. I think that's something that here on Earth we take for granted.
Yeah.
The combination of convection on Earth and just fans moving air around, and also gravity and stratification of the density of fluids. So carbon dioxide being a little more dense than nitrogen and oxygen that primarily make up air, really allows that carbon dioxide to sort of get out of the way. On Space Station, it is an enclosed space, so all of the carbon dioxide that the crew are breathing out.
Dragon SpaceX, there is an OOP burn coming up in 7 minutes.
Dragon copies.
So core letting the crew there know about the upcoming out-of-plane burn. But as I was saying, the carbon dioxide will tend to build up unless there are fans and filters to capture that. So the circulation step here is to try to get some of that air circulating, make sure that there's no unexpected or sort of stale air in that hatch. And actually, Dragon has similar measures on the spacecraft to make sure it's circulating air and cleaning up that cabin environment for Bob and Doug.
Sorry, I'm trying to hold it together for a minute. We heard them call it the OOP burn, and my colleague just said OOP. There it is. The OOP is the out-of-plane burn, and as we described, as they've made all of these careful approach burns.
Dragon SpaceX, we are also less than 2.5 hours to the earliest docking time.
Dragon detector readings, if you're ready to copy, Anna.
I am ready to copy.
For the detector 1, L reading is 0.0. Detector 2, the CO is 8 parts per million, and the HCN reads negative 0.4 parts per million. How copy?
I copied HCl 0.0, CO 8 parts per million, HCN negative 0.4 parts per million.
Good copy.
Thank you so much.
We will turn them off and then put them back in volume 14.
Perfect. Thank you.
So the core, Anna, they're letting the crew know to do a quick functional test of the handheld gas detectors. We have a few of those on board Dragon. If there were to be some kind of an anomaly on board the spacecraft, they help the crew diagnose whether there's any kind of an emergency situation. Just doing a quick check, making sure they're functioning as intended.
Yeah, we heard them checking for 3 different ones, and they were HCN, hydrogen cyanide, HCl, hydrogen chloride, and CO, carbon monoxide. And again, these are detectors. They are in a closed environment, so all of their atmosphere is in there with them. So onboard Dragon, and also once they're onboard station, there are always a number of detectors set up throughout, just looking for any trace contaminants, as we call them. So any very tiny bits of any of these substances that are used in spacecraft for anything from cooling the vehicles, being fuel, refrigerants, things like that, just to make sure we always have a safe breathing atmosphere through that life support system for our crew members on board. So yeah, they went through. We heard a confirmation just on our side from our life support officers in the control rooms, everything at the expected values, no concerns, and they were able to switch those detectors back off.
Yeah, and shortly here, actually, the crew, so once we get the go-ahead to do the approach initiation, the crew will also begin to don their suits. So those cool suits that they had on during the ascent portion, they'll put those back on, go through some leak checks on those suits, make sure that they're good to go, because they are getting pretty close to the space station. It's a relatively dynamic phase with a number of burns and attitude, thruster movements of the spacecraft to try to make sure you're completely centered and pointed relative to the International Space Station. So we just want the crew to be safe in their suits in case anything were to happen. They're safe and ready to go. And those suits can provide nitrox, which is a mixture of nitrogen and oxygen, or pure oxygen to the suits if the pressure were to get low enough in the cabin.
Yeah, but meanwhile, we are counting down to another burn. This is going to be a really small adjustment coming up in about a minute. It's an out-of-plane burn just to really fine-tune their path and set them up for that approach initiation. Only going to be changing their velocity by about 0.66 meters per second. So again, just a really slight adjustment to the Dragon spacecraft's velocity as we get closer to that approach initiation burn, which is when things are really going to start to pick up. And again, we're tracking that in under an hour from now at about 5:09 a.m. Pacific, 12:09 GMT. So we'll stand by for one more burn. Again, we'll wait to hear out once it starts. This one's planned to be about 40 seconds in length. Again, firing those Draco thrusters to begin moving Dragon just a little bit closer, just fine-tuning its path right now before we get to approach initiation.
Yeah, and actually from we saw during the 5 sort of big burns that happened earlier in the mission that the Dragon spacecraft reoriented itself. So it did what we call a slew maneuver to try to get those forward bulkhead Draco thrusters, the ones that are underneath the nose cone, or rather protected by the nose cone during the ascent portion, to get those Draco thrusters to provide most of the momentum to the spacecraft. For most of the burns going from here on, we'll actually be using the service section thrusters. So there are 12 Draco engines that provide attitude control and small thruster corrections as we make these fine-tuned approaches to the space station.
And I mean, just watching the data, it's been all service section Dracos for this burn so far. So again, just a really slight burn, just to really fine-tune our path, to put Dragon in the right position before that approach initiation.
Dragon SpaceX, OOP burn complete, nominal burn.
And once again, OOP, there it is.
Dragon copies, nominal OOP burn. Thanks, Anna.
So one more nominal burn in the books. We are now 53 minutes away from the planned approach initiation. So before we get there, they are going to do a go, no-go between the teams, both in Hawthorne Mission Control right behind us and with the teams over there in Mission Control Houston. So they'll do that about 20 or so minutes before they get to the actual burn itself, which we are still tracking for under an hour from now, 5:09 a.m. Pacific, 12:09 GMT.
Yeah, and it's really a chance for all of the subsystem area experts, so the folks who really understand the avionics and the guidance system and the propulsion system and their counterparts on the station side, to really take a look at the data on both spacecraft, make sure that both vehicles look healthy before they start going into what are a little bit more risky operations, because you're getting closer to the space station. Bob and Doug actually touched on it, and we've talked about it a few times. They're going about 17,500 miles an hour right now, which is just it's really, really fast, incredibly fast, especially when you put into perspective that most commercial airliners are around 500 miles an hour. So things happen very quickly unless you're very controlled about your approach maneuvers. And so these go, no-go polls serve as opportunities for the ground teams to feel confident that the spacecraft is going to perform as expected.
So with that out-of-plane burn now in the books, the crew should be getting to go to start their suit donning in the next 15 or 20 minutes. And that'll be one of the go, no-go criteria we look for before they get to the approach initiation burn. And so we'll hear them. We saw they had the suits in bags just strapped into the seats next to them, as both seats 1 and 4 inside the spacecraft empty for this. So Bob and Doug able to store their suits in those seats. So it was pretty cool seeing them strapped in, almost like we saw Ripley strapped in last year on Demo-2. But they'll get into their suits and get strapped in, and then once again be monitoring those touchscreen controls, just watching Dragon systems as they start to move through the final approach.
Yeah, and the ground side and, of course, Bob and Doug on the vehicle will have some steps that they need to do here. We talked a little bit about suit donning. The ground side will actually give them a call, let them know that they're go to put on their spacesuits. Once they get into the spacesuits, there's a few checks that we need to do.
Dragon SpaceX for suit donning and pre-suit donning activities.
There it is.
Go ahead.
We are ready for you to step into suit donning a little early, and we have a couple of requests for you before you do so. Let me know when you're ready to copy.
Sit on 2. Hey, Josh, are you guys seeing what you need to see from the cupola SSC?
We're ready to copy, Anna.
We're checking.
The first is that we noticed that the carry-on bags are temp stowed in the cabin. We ask that as a part of your suit donning that you please re-stow those because the material that they are made out of is a flammability risk.
It all looks good, thanks.
Okay, great.
Okay, we'll re-stow those.
Thanks so much. Secondly, a reminder to please power off and clean each of your displays using your comfort garment, and then power back on as a part of your suit donning.
Okay, we will power off via the push buttons each display, and then clean them with a comfort garment, and then power each back on. How copy?
That's a perfect copy. And we will be putting the external video configuration in work as we speak, and we'll let you know when that's ready for your suit donning.
Okay, sounds good.
So the Corps there letting the crew to do a few actions. They talked about cleaning up the displays a little bit, making sure that they're nice to go before they step into that manual piloting test later on. Also the suit donning and camera reconfiguration, so give Bob and Doug a little bit of privacy while they slip into those spacesuits. And they actually mentioned the comfort garment there. It's actually it's a layer that they wear underneath the suit. It's kind of like soft, comfy material. I kind of think of it like soft, comfy pajamas, but it's like athletic material that they can use for soft touch cleaning items.
Yeah, one of the most common questions we get when we see spacesuits is kind of what's underneath, because we know that there's a lot of layers built in. For the large EMUs that they'll wear once they're doing spacewalks on board, which Bob Behnken received some training for, and we might be seeing him go out the door with Station Commander Chris Cassidy, who we can see start to peek into view there on the International Space Station. They have an actual liquid cooling garment that's flowing cool water, but I know the SpaceX suits were just able to use some cool air flowing through those umbilicals to help keep them cool while they're inside those suits. Because, I mean, we've called them kind of mini spacecraft inside a spacecraft. You're in a sealed environment, essentially, when everything's zipped up. So it can get kind of warm if you're just sitting in there by yourself.
Yeah, absolutely. And actually, I think it's something important to make the distinction there that the SpaceX suits are what we call IVA suits, or intravehicular activity suits. If you're thinking about, the EVA suits or extravehicular activity suits, they're a little bit different. The suits provide some protection. They've got that 3D printed helmet portion with the integrated mics. So of course that protects if the crew were to get a little bump or something during the ride or during some of those dynamic maneuvers. But more importantly, the suits provide protection if there were some kind of a depressurization event in the vehicle. If we were to somehow lose cabin pressure aboard, then those suits would inflate and keep pressure on Bob and Doug. Since we have about 14.7 psi depending on where you live on the ground, so the Dragon cabin's roughly about that as well. So it tries to keep them at an appropriate positive pressure differential to keep them safe. So the suit's important function for all the safety activities for the ascent portion. They also actually have some restraints.
And Dragon SpaceX cameras are now external.
It sounds like we're getting a lot of camera configuration work right now for the ones on Dragon. They're external now. For on station, we see Chris Cassidy. He's going to do his best.
Dragon copies. And with that, Anna, we'll take that as our cue to start transitioning into our undersuit garments.
You are go.
There we go. Bob and Doug getting the go to start their suit-up procedures from the Corps here in Hawthorne and in Behnken. Meanwhile, though, again, on board the space station, Chris Cassidy getting some cameras set up So we hopefully get a pretty good view down that PMA hatch. It's a bit of a tight squeeze. Again, just as a data point for you, when that A-pass hatch is open, they only have a little over 30 inches between the attachment point of that hatch and the bottom of the pressurized mating adapter where they're going to be coming through. But definitely big enough for the crew and definitely big enough for cargo that this version of Dragon's going to be bringing up on future flights starting later this year. It'll be the first flight of a cargo variant of this spacecraft, which, I mean, even that in of itself is going to be really exciting. There have been over 20 cargo deliveries on the original cargo Dragon, which all went through this berthing procedure. To see one come up for cargo and dock that's just going to be another first that we have. So 2020 is already being a year of a lot of firsts, and still a lot more to come.
Yeah, in fact, actually on those Cargo Dragon missions, a couple of the early Cargo Dragon missions actually brought the international docking adapters that both the Demo-1 vehicle and hopefully today's Demo-2 vehicle will attach to. And when we got that awesome look inside the Dragon spacecraft earlier with Bob and Doug, we got a little look at some of the cargo that they have underneath the seats. So they had a few cargo pallets and storage items down there. And, you know, this version of Dragon can also hold a decent amount of cargo in the pressurized section of the vehicle. So nice to see that all that is being taken advantage of on this test flight.
Yeah, and if you give me a few minutes, I could pull up the manifest for this flight. A lot of the cargo on the way uphill is things like vehicle spares, some hardware specific to Dragon itself that's going to stay on board station for future Dragon flights. They have some cold freezers on board, which are empty right now on the way up, but those are going to be packed full on the way back down. One thing that Dragon's always provided to the International Space Station is the ability to bring cargo home, as even the cargo version of Dragon had that heat shield and survived the heat of reentry to splash down in the ocean. And that's critical for bringing a lot of these science samples back down to Earth for analysis. A lot of the science gets done on the station, but you don't have an entire analysis laboratory which are spread out all over planet Earth. So Dragon capsule has always been able to bring some of that cargo home, and when Bob and Doug come home in a couple of weeks or a couple of months, they're going to be bringing down a whole bunch of science samples. A lot of the stuff that goes into those cold sections and it gets a little gross, but it's a lot of the human research samples, so samples from the astronauts themselves. We don't like to call them guinea pigs, but they are the research subjects for a lot of the academic research being done on board the International Space Station.
Yeah, some of the crew members have been on, up to a year up there, and microgravity is definitely a different environment from Earth because you're constantly in a state of free fall. So subtle changes to the inner eye, subtle changes to your bone density, all kinds of things that I'm sure there's awesome research going on in the station.
Hey, affirmative, copy that.
I also want to check the cable routing for this camera.
Roger.
So pretty cool that Dragon can bring those cargo samples back and enable better understanding of human physiology in space for some of those deeper exploration missions that are hopefully to come.
Yeah, we have a bit of a backlog still of just all of these cold samples, and these are samples that we have a number of freezers like the Melfi, the minus 80-degree laboratory freezer on board the International Space Station, that you have to keep them at these very cold temperatures just to preserve them for further analysis down here on the ground. And so Cargo Dragon, not only delivering crew, but also going to be delivering some of our science samples back down to planet Earth. So it'll come from a lot of those human research studies. There have also been a number of rodent research studies on board the space station, pharmaceutical companies doing research for drugs ranging from cancer treatment to a number of very specialized diseases like Duchenne's muscular dystrophy. So a lot of this work being done on board the International Space Station, not just to learn more about flying in space, but to benefit life back down here on Earth. But we're getting some cool views inside the space station right now. Let's go down to Gary in Houston, check in with the station team. They're doing some final work to get the station configured for this approach and docking. Over to you, Gary.
Thanks, Dan. That's right. A lot has already happened. We are right on the timeline, ready to receive Bob and Doug here at the International Space Station. You're getting a look from the inside of the space station at the forward end, right where Chris Cassidy is, down that hatchway. That's where Bob and Doug are going to be docking. That's called the pressurized mating adapter. Chris Cassidy opened the hatch to essentially ventilate that pressurized mating adapter. That hatch normally closed for day-to-day operations, but opening it up allows the air from inside the International Space Station to circulate inside and really get rid of some of those CO2 pockets. One of those things you got to worry about when you're in the microgravity environment. But now that the air is circulated in the pressurized mating adapter, we got good ventilation of that segment of the space station. Cassidy's prepping the pressurized mating adapter to close the hatch there. Just don't want anything floating in while we have a good mix. So just an extra precaution before we get towards the docking of Bob and Doug. He's also configuring some cameras. You're getting a view now. That's one view that we'll be able to get from the inside there. Should be a few more coming shortly. Chris Cassidy has also completed a rendezvous conference to go over the procedures, everything he has to look forward to for the monitoring of the approach and docking of Bob and Doug here shortly. The International Space Station itself is also being configured for Bob and Doug's arrival. Attitude has been switched to proximity operations, and the solar array joints, the solar alpha rotary joints, are being configured to be locked. This is, again, one of those precautions needed for Bob and Doug's arrival. Everything is on track. We're a little bit less than an hour from bidirectional communications with the C2V2, common communication for visiting vehicle. There's one on the space station, also one on Dragon. That bidirectional communication will allow some good solid video, audio, and telemetry data to be exchanged from between Dragon and International Space Station. Dragon at that time won't need to rely on TDRS satellites and the ground stations. Really, everything can be accomplished through that C2V2 link. That's coming up here in just a little bit less than an hour. Also about that time will be the go, no-go for approach initiation, joint operations coming up on the space station very shortly, and of course the Attitude will be configured for docking, those thrusters on the U.S. side being shifted over to the Russian side. Don't want any of those plumes interfering with Dragon's docking. Everything's going according to the timeline here from Mission Control Houston. We'll send it back over to you at Hawthorne for some of these next few steps.
Awesome. Thanks, Gary. That's a cool update to hear about all the cool research and the next steps coming from your perspective, too.
All right. Well, yeah, just another time check-in. We should be getting the go, no-go for that approach initiation within the next 15 minutes. That's something that's going to be on internal loops and nets with the SpaceX and NASA team. We'll be able to report to you once we get a go or a no-go, but everything's still trending towards the go. We've not had any issues with Dragon on the whole way uphill until this point. All of our burns have been nominal. We had those 5 major ones to get us in this close proximity to the International Space Station. Right now, they're only 16 kilometers away, just about 10 miles. They're going to continue to close in until they're about 7.5 kilometers, and then we'll be able to begin that approach initiation.
Yeah, currently Bob and Doug are getting into their suits. As they get into their comfort garments and then eventually get into the entire suit, then they'll let the ground team know. And then there's a couple of pressurized leak checks that we'll do on them, just to make sure that the suits are leak tight, and if there was any reason why they would need to pressurize those suits during the approach portion, then they'll be ready to go for that. They also stowed a few items in the cabin, getting it cleaned up. We like to keep the cabin relatively clean just as an operational control anytime we're doing any kind of burn or maneuver. Of course, as the spacecraft accelerates, anything that's not locked down or Velcroed down will move around the cabin until it sort of gets pushed along by the spacecraft. So we try to keep those things stowed away for most of the flight, and Bob and Doug actually talking about that a little bit after their crew sleep period, where they said, hey, the spacecraft's relatively clean after a couple people have lived in it for a day. So nice to see that they're getting ready for the approach initiation maneuver.
All right, well, we'll hear that go, no-go internally in a little while. We are tracking to about a little under 38 minutes from that approach initiation burn. At that point, we're going to start getting into some of the different waypoints. Again, there's 3 waypoints on our final approach, waypoint 0, 1, and 2. There's going to be a couple where we might pause. We might go right through waypoint 0 and waypoint 1. And then right after we get past waypoint 1, we're going to do a commanded hold at 220 meters away from station.
Yeah, the 220 meters is actually pretty intentional. If you can see on your screen now, there's something called the keep out sphere. That's a 200 meter radius imaginary sphere around the space station, and that's really to protect the crew both aboard the space station and the visiting spacecraft. It's really intended to be a control, so that if the ground teams in Hawthorne and Johnson Space Center see anything wrong with the vehicle, then they can troubleshoot those issues before doing that final delicate step of docking. When they get to that 220 meter hole, which the crew are going to command, then the crew aboard are going to do a quick manual piloting test. They actually did one of these in the far field, which just refers to being relatively far away from station. In this case, Bob and Doug will issue some commands using those touchscreen displays in the Dragon spacecraft to a few quick bursts of translational thruster fire. So what that means is if you imagine Dragon pointed at the space station, they're going to go left, go right, go up and down a little bit. And then once they've confirmed that they're able to issue those commands, they'll switch it back over to Dragon for final approach. There'll also be a go no-go poll there from the joint operations team, Hawthorne and Johnson, before that happens.
Yeah, and we'll have that final hold once we get into waypoint 2, and Dragon will only be 20 meters away from the space station. So it'll be lined up perfectly in front of that docking adapter at the very forward port of Node 2, the Harmony module. It'll hold at that 20 meters. Shiva said we'll do a go, no-go poll, and then they'll get to go to press in. Dragon will approach extremely slowly. And it's going to slow all the way down to about 1/10 of a meter per second or even slower as it does this final approach. At one point, we may hear something called CHOP, or crew hands-off point, and this is just a call out for the crew to know that they should not be sending any commands, because at that point, the Dragon vehicle would be the only one able to make any aborts out of that zone, and that's literally when we're just about 2 meters away from the space station, so when we're really close. We'll get that initial contact and capture, which we were tracking for about 7:30 a.m. Pacific time, or a little under 3 hours from now. And then they'll wait for the relative motion to damp out, and then they'll begin to retract that soft capture device and get a hard mate, and we'll get the docking complete call. Meanwhile, though, we're getting some views back inside of station. Chris Cassidy getting everything ready for his crewmates, Bob and Doug, who are about to be arriving on board, hopefully in the next 3 hours.
Yeah, and we were talking a little bit about the docking maneuvers there. When we get to the actual stage of docking the vehicle, Dragon has a docking structure on the top of the vehicle that's normally protected by the nose cone during the ascent portion. Now, of course, the nose cone is open, and the sensors and the docking system underneath it are exposed to space. And so on that docking ring, there's actually 3 pedals that'll interface with the International Docking Adapter. They've got a ton of sensors and switches on them that'll detect whether we've made good contact with the space station. And then, of course, both the spacecraft are going really fast. They may have small relative motions in between them. So the docking system for that first soft capture will actually damp out some of that relative motion. And once that motion is damped out and both the space station and Dragon are stable dynamically, then we'll actually retract the soft capture hooks. Dragon will get pulled in towards the IDA, and then a set of 12 hard capture hooks on the ring will interface with the docking system and confirm that good hard seal. And that'll create something called a vestibule between the Dragon spacecraft and the International Space Station.
All right, we are coming up on 6 minutes from our anticipated go, no-go poll for the teams. We can hear the lead flight director for Demo-2 for NASA, Zeb Scoville, polling his teams in Mission Control Houston, getting them ready. So we'll report on the results of that poll as it completes. We are about 31 minutes away from the planned start time of the approach initiation burn. Again, we're tracking to right at about 5:09 a.m. over here on the West Coast, and that's 12:09 GMT for those of you around the world. And that's going to be the major burn that's going to be bringing us in really close to Dragon. We're going to go from several kilometers away to being only 500 or 400 meters away from Dragon at the end of it. The approach initiation burn planned to be about 90 seconds, so about a minute and a half firing of those thrusters on the Dragon spacecraft. Just, again, swinging it up. We're at an orbit roughly co-elliptic still with the International Space Station, about 2.5 kilometers below, and just continuing to close in. As of this moment, the Dragon spacecraft just about 14 kilometers or 9 miles away from the space station.
Sim 2, I put the spare 8-pass hatch standoff assembly back in its kit in PMM P2D.
Copy, Chris. PMM P2 Bravo.
Delta P2 Delta.
P2 Delta.
Gotcha. Anything I can get ahead on in stuff? I guess the only thing that appears on the Optimus is the i6 Experience camera. Other than that, it's just kind of waiting for stuff to happen, I think.
That's the affirmative from our vantage right now, Chris. We are going to be doing a bunch of big loop comm checks here. That's kind of next on the agenda. It's not on your timeline, but I'll give you a heads up on it.
Okay. About what's the ish time frame on that? Like an hour, 2 hours, less, more?
We're inside of the 5-minute window on it, and this will just be Cor and myself talking between you and Dragon and making sure all the elements of the big loop are in place.
Copy that. We're using Space to Ground 1 for the big loop, correct?
It'll be Space to Ground 2.
Glad I asked. Thanks.
And that was just a quick conversation between Chris Cassidy, the commander on board the space station right now, and Josh Kutrick. He's a Canadian Space Agency astronaut who's serving as the Capcom right now in the flight control room over there in Houston. You heard him talk about the big loop coming up. And so this is what we talked about a little bit earlier, where they're going to now be mixing the communication between the team here in Hawthorne and Dragon, which is done over Dragon to ground loops, and the team in Houston.
Dragon SpaceX on Dragon to ground. The 144K bidirectional link has been established. Please change your push-to-talk destination to ISS and then initiate a comm check.
So we're hearing a bidirectional communication link between Dragon and the station has been established, and we're going to be coming up on a series of communication checks, kind of similar to what we heard.
Okay, Anna, we'll put that
similar to what we heard pre-launch, where several parties went around and did communications checks with each other. Pretty soon we're going to have all of the audio tied in, so from the core here in Hawthorne to the crew on Dragon.
And Dragon, this is Houston. We have you loud and clear on the big loop. Stand by 1. I'll try to get SpaceX up.
Okay, Houston, we copy you also on the big loop. Great to talk to you guys from a brand new spaceship.
Yeah, likewise, a bunch of smiling faces here. It's good to talk to you, Doug. From SpaceX, they did return your call on the big loop, so I just want to make sure you did not hear from SpaceX. Is that correct?
Correct, Houston. We did not copy SpaceX. We have heard your minutes on the big loop, so we have been hearing both you and the station, but I don't believe we've heard SpaceX on.
Okay, Bob, we copy, and let us just have a look at that. We'll get right back to you.
Doug promises he'll make it up for you next weekend.
Sounds good. Really looking forward to it, gentlemen. Have a great dock.
And we've started some communications checks. So on the big loop, so again, we're now tying together communications from the core here in Hawthorne to the crew on Dragon, so they can also talk to the crew on station and also talk to the team there in Houston all simultaneously. So it's called the big loop. It's just tying everybody together. We got that first exchange between Bob and Doug and Chris on the space station, so they're going to be able to talk directly to each other. Everyone's just going to be tied in as we get closer to these integrated operations.
Yeah, a lot of what we've been hearing on the way is what we refer to as Dragon to ground, and in some cases space to ground. So the big loop really just tying all of those different nets together so everyone is communicating at the same time. And in the operations room, really any time that the crew aboard station or on a vehicle speak up, the ground team really wants to be listening. So having everyone on the same loop helps us make sure that we're listening for anything that they may have any sort of urgent communications.
And so they did have one issue that they're going to troubleshoot. The crew not able to hear the core here in Hawthorne on the big loop, so they're going to get that figured out and get that integrated in. Right now, though, we're standing by for everyone to finish their go, no-go for approach initiation. So that should be coming up any time now. We're about 22 and a half minutes from the planned start of that approach initiation burn. And again, this is going to bring us from about 7.5 kilometers behind and 2.5 kilometers below the station all the way up to 400 meters directly below the International Space Station. And we should hopefully be coming up on some daylight pretty soon, and we might be getting some more views from the station of the Dragon capsule.
Yeah, right now that approach initiation burn, I believe about 22 minutes or so away. Definitely about 20 minutes away. But of course, have to get through that go, no-go poll. Have to make sure that everyone on the ground teams feel comfortable with spacecraft health, that everything that can be stacked up for success is successful.
Sounds like we're getting. So still just troubleshooting, trying to get the core